Hey folks, welcome back to section 7.1 where we are dealing with some trigonometric identities. If you will go down to where we left off, I actually did forget to fill in a blank for you, so let's go ahead and fill that in really quickly right at the end of example number 1. When you are taking the square root, just make sure that you choose a sign based on the quadrant of theta and the function that's being evaluated. So in other words, this is just a reminder to pay attention to your pauses and your negs. All right, now let's take a look at the rest of the examples for 7.1. You'll notice that we've got these separated here, so I'm just going to zoom in on example number 2 only. This says that we should write tangent of theta in terms of cosine theta. So in other words, when we're finished, we don't want any tangents in what we are writing. We only want cosines in what we are writing. Now, I have added on a bit of instructions here, and that is to give a reason for each step. You need to be aware of how to do this, and you need to practice doing this. Make sure that every single step you write down, you are able to give a reason for what you wrote down. All right, so honestly, what you're going to be using, let me scroll up here for just a moment. These fundamental identities, these are going to be the most common things that you use. Sometimes you'll use math, like adding and subtracting of fractions, or get a common denominator, or multiply two fractions, things like that. But frequently you will use these identities. All right, so we know that tangent is equal to sine theta over cosine theta. How do we know that? Well, we know that because it's a quotient identity. So what we've done here is I've taken tangent out and I've substituted what it was equal to by using the quotient identity. All right, well, unfortunately, this is not in terms of cosine only. This is in terms of sine and cosine. So I need to take this a little further. Now you remember in video number 1, I'm actually going to direct you back to this. In video number 1, I showed you that frequently we can isolate not just a sine squared, but we can actually isolate a sine of theta if we wanted to turn it into something that deals with cosines. And that's what we're going to use down here. Notice that sine of theta is equal to what we just wrote down, plus or minus the square root of 1 minus cosine squared. Again, that's from that reflection question that we did in the first video. Cosine, I'm just copying. I didn't do anything with the denominator down here. Why was I allowed to do this? Well, this was one of my Pythagorean identities. So I could have put here either Pythagorean identity, and I'll add that here, Pythagorean identity, which was, then I used substitution. All right, so at this point, notice that I have taken tangent, I've rewritten tangent, and notice that the only trig function that I'm using now is cosines. So I've written my tangent in terms of cosine. All right, let's go to example number 3. This one says write in terms of sine and cosine. Now, I want you to understand when you see this particular phrase, in terms of sine and cosine, this is simply a hint. It's not telling you how your answers should look, because notice, not only does it say to write in terms of sine and cosine, but then there's a second part of the instructions. It says then we need to simplify. So just putting in terms of sine and cosine will not be simplified enough. So just pay attention to the instructions when it says things like this. All right, so here we go. And by the way, it does say simplify so that no quotients appear. We don't want any kind of fractions remaining. All right, so let's pick this apart. Notice that up on top, 1 plus tangent squared, this is one of our Pythagorean identities. So let's substitute what it equals. That's the same thing as secant squared. And we also know that 1 minus secant squared is going to equal a negative tangent squared. Now, how do I know that? Again, this is a Pythagorean identity, so I'm going to go ahead and uncover my reason there. It's a Pythagorean identity, and it's just simply reworked rearranged to get that negative tangent squared. If you go back up to your Pythagorean identities up here, if I took secant squared over to this side so that it was 1 minus secant squared, I would take my tangent squared to this side, making it a negative tangent squared. So it's just a rearranged Pythagorean identity. Now, I'm not doing what I was told to do, though. It told me to put it in terms of sine and cosine. So let's go ahead and do that next. We know that secant squared is the same thing as 1 over cosine squared by the reciprocal identity. And we know that tangent squared is the same thing as sine squared over cosine squared. Don't forget your negative that goes along with that, and that's a quotient identity. Now, I have all sines and cosines, but it's definitely not simplified, and I also have quotients, so this is a problem. So let's go ahead and keep on cleaning up here. Notice that I am dividing two fractions, and we know that the rule for dividing fractions is to multiply by the reciprocal. So that's the next thing that we're going to do. Here's my 1 over cosine squared. I'll get rid of that. And then I also have my cosine squared. Let me see if I can get rid of this without messing anything up. No, I did not, but that's okay. I'll put my theta back in there. And so all I did here, notice that this is multiplying the reciprocal of this. And now I've already messed it up. I've already given, spoiler alert, I can cancel the cosine squared on top and the cosine squared on bottom. Now, before I do that, what was the reason that I wrote down this whole entire statement? Well, I was just dividing fractions. All right, so now let's go ahead. We're going to multiply our fractions, and when we multiply our fractions, we're going to have a 1 on top, a sine squared on bottom. Don't forget that negative that goes along, so that's just done by multiplying fractions. We could say that we also canceled. Again, when we go back to the instructions, it says to simplify so that there are no quotients in our final answer here. And so the last thing I need to do, 1 over sine squared, is the same thing as cosecant squared. Don't forget your negative, tag along, and we know this because of the reciprocal identity. All right. Little statement here, when working with trig expressions and identities, be sure to write the argument of the function. For instance, is it correct to write sine squared plus cosine squared equals 1? And you know, this is a little confusing because on this video, you've heard me say that very thing, sine squared plus cosine squared is equal to 1. But what you haven't seen me do, even though you've heard me say that, you haven't seen me write that. Sines and cosines must. In fact, all six trig functions must have an argument. They must have an angle that goes with them. So the way that this has to be written correctly would be sine squared theta plus cosine squared theta is equal to 1. So what I tell my students when I'm with them face to face, it's totally fine to be lazy in our speech, but we may not ever be lazy in our handwriting. So just be aware of that. All right, so let's do a few more of these. Our directions here say to write the following in terms of sine and cosine. Then we're supposed to simplify. And once again, we're supposed to simplify in such a way that we have no quotients in our final result here. Now, please understand, folks, this is one of these sections that I look very heavily at the work that you write down for your test. So make sure that you don't skip steps on these. I need to be able to see what you're doing. And once again, get in the habit of always writing a reason for every single step that you write down. All right, so for tangent, I'm going to replace tangent with sine theta over cosine theta. And for cosine, I'm just going to copy it as is. But since these are fractions, oh, by the way, my reason for that was the quotient identity for tangent. And then I can multiply, but notice that before I multiply, I am allowed to cancel that pair of cosines. And so when I multiply, I'm going to get sine of theta, and that's just done by multiplication. All right. All right, part B. And remember, all we're doing here is simplifying. That's all we're doing. We're not trying to find anything. We're not trying to solve for anything. We're just simplifying the expression. Now, there's a couple of things that you could potentially do on this one. My brain goes in multiple different ways on this. So there's one option, and by the way, they're all correct. They're all legal. One thing that you could do is you could turn your cotangent and your tangent into sines and cosines. That's option number one. Option number two, you could distribute. Option number three, you could, by the way, rewind. When I distribute, I would be doing this kind of a number. Option number three, you could use a Pythagorean identity, realizing that 1 plus tangent squared is the same thing as secant squared. And so you could just substitute secant squared in for that quantity. All right, so let's go ahead and take a look at what I did. So let's uncover the first step. The third option is what I decided to use. Now, I'm not going to work all three options for you, but just realize if you work a different option than I do, it might be still every bit as legal and valid as the one that I did. So we just mentioned that the reason that I did this was because of the Pythagorean identity. And then what we'll do next is we'll go ahead and turn both of these factors into sines and cosines. So we've got here cotangent squared is the same thing as cosine squared over sine squared. And secant squared is the same thing as 1 over cosine squared. So this was actually done by two different identities. The first one was by the quotient identity, and this one was with the reciprocal identity. All right, you'll notice that we've got some things that we can cancel out. And so we can multiply what's left, which is going to be 1 over sine squared. And we know that 1 over sine squared is the same thing as cosecant squared by the reciprocal identity. So we have made it simpler. We have no quotients in our final expression. All right, let's go to part C. So for part C here, there again are multiple options. The first thing I want to point out though is that you may think that I can use a Pythagorean identity, but there are no squares here. So since there are no squares, you may not use a Pythagorean identity. What I'm going to do on this one is notice that I have a common denominator. Common denominator is cotangent. I'm going to make that common denominator uncommon. So I'm going to, in class, I say that I'm going to share the love. I'm going to take that denominator, make it an uncommon denominator, and share it with my two separate numerators. So what we have here then is, well, nope, that is apparently not what I did. So let's rewind on that statement. I am so sorry. Well, that was definitely an option. It's a correct option, but it's not the option that I chose. So what I decided to do is I changed my cotangent into sines and cosines. And I am going to do this by using the quotient identity. Sorry about that, folks. On bottom, I'll do the same thing, cosine over sine. And then at this point, I'm going to multiply by the reciprocal since I'm dividing fractions. Here's my reciprocal of the denominator. So I'm going to divide fractions here. And then the next thing that I'm going to do is I'm going to distribute. So I'm going to take this fraction and multiply it by the 1, which is where you get sine over cosine. When I take this fraction and multiply here, notice everything's going to cancel out. You'll have a pair of cosines that cancel, a pair of sines that cancel. So that's why I'm left with just a 1. So that was all done by distribution. And we know that sine over cosine is the same thing as tangent. And so we can substitute a tangent in for that, which is done by the quotient identity. Now, just for fun, because I started you out poorly on this, this is actually done by following the directions, because the directions did say that we should use sines and cosines. But let me show you what this would have looked like if I had shared that common denominator. So if I take this and I share that denominator, that's going to be a 1 over cotangent theta plus cotangent theta over cotangent theta. And so then you'll notice that the cotan over cotan gives me just a 1. And so this is going to be 1 over cotangent plus 1. And we know that 1 over cotangent is the same thing as tangent plus 1. So this first one then was simply using the concept of common denominators. And then I simplified. Oops. And then I used a reciprocal identity. Okay, so that method was actually a little bit shorter. Granted, it does not follow the directions because the directions talk about using sines and cosines. But just for fun so that you can see another way that you could have worked the same thing, and that would be totally just fine. All right, let's look at part D. Now, I've given you a hint here. The very first thing that we're going to do is we're going to FOIL. So first, outer, inner, last, you guys know what that means. So if you want to pause the video and you actually want to go ahead and FOIL these out and see if you get the same thing that I did, that would be perfectly fine. So go ahead and do that. All right, the second thing that I did was I started to look at my reciprocal identities. So notice that these two are reciprocal identities of each other. So sine times cosecant is always going to equal 1 because they are reciprocals of each other. You notice that the exact same thing occurs down here at the end. Cosine and secant are also always reciprocals of each other. And then the minute you've got a 1 minus 1, those two are going to go away. They are going to just zero each other out. So that all I'm left with are these two terms right here in the middle. And this first term, sine over cosine, is the same thing as tangent. Cosine over sine is the same thing as cotangent. So here I'm using my quotient identities and substitution. Or subtraction for the ones, I guess is what that says. All right, and I think we got one more. Yeah, this is the last one. Okay, so for secant squared theta minus 1 over cosecant squared theta minus 1. Now, I have no idea what is underneath my step 1. I would suspect that it says tangent squared, and I would suspect that the bottom one says cotangent squared, but after the last question, I'm not entirely certain what it says because it's been a couple days since I hid this. So let's find out what's behind door number 1. Okay, oh good. I use the Pythagorean identity here. Secant squared minus 1 is the same thing as tangent squared, and cosecant squared minus 1 is the same thing as cotangent squared. And then what I decided to do was I turned just the denominator into 1 over tangent squared because they are reciprocals of each other. And so that was done by the reciprocal identity. And then I could divide my fractions by multiplying by the reciprocal. Sorry about that. That's enough. And then tangent squared times tangent squared is the same thing as tangent to the 4th power. And that's just done by multiplication. All right, and that wraps up this particular video and this section 7.1.